because this is the elasticity of demand. So this is a formula you will need to know for this section. And of course, all the other concepts that we covered, because you will see that it does involve differentiation. So we have to take the derivative of the demand function as part of this formula. Now, once we calculate this elasticity, we're going to either get three values. We're going to get a number that's less than 1, we're going to get a number that's greater than 1, and we're going to get unit elasticity. So let's talk about the first one. So total revenue is increasing at those x values for which E of x is less than 0. So this there's actually a term for this. It's inelastic. Now, what does that mean exactly? It means that when we change the cost of a product, the revenue normally does not change, or it changes very little. So we can increase the price of some product and people still buy it no matter what the cost. Can anyone think of a product like that? Gas, there you go. Gas is a good example. So we have, gas, right now the gas price has been going up over the past few months, and we're still basically just buying the same amount of gas. I don't think many of us have reduced the amount of gas we have purchased. Anything else? That's it? Would you consider alcohol an inelastic product? Yes or no? There's 30 you signed in, 29 plus myself. So, does anyone in here consider alcohol an inelastic product? Meaning if we raise the price, people are still going to buy. Thanks, Michael. How about the other 28? All right. We're getting a few responses. Anyone else? No one else? Damon, what do you mean by people need to get drunk?
Yeah, everybody just wants to have a good time, so they wouldn't mind.
Some of my friends had an adult Easter egg hunt yesterday. And you know what they put inside? Those little shot bottles. You guys have fun. Only Mike Haley likes that. All right. Let's So how about the elastic product? Those whose revenue will decrease if we raise the price. Is there something that if they raise the price, you are not going to buy it? Are you going to buy less of it? Jehan, for example, what? What would you not buy if they raise the price?
Um, like everything.
Anything?
Well, I guess
No.
like if the prices of everything goes up, I would just be more mindful about what I buy.
Yeah. Yeah, but like what? What does one of those with it? Maybe some food items, right?
Yeah, maybe I would go to a different grocery store.
True. We'll change from some of the high end to some of the low end grocery stores,
Yeah,
clothes, new said, that's true, right? And I guess it varies from consumer to consumer, but in general, there's some general trends among it, like, gas. I don't think you have reduced your gas consumption, have you? In the past year, and gas prices have gone almost 50%.
wait, are you asking me?
No, well, I
Oh,
was saying, did you reduce your gas consumption in the past year?
I
You
don't think
drive?
so.
No, you still go to the same place you used to go to, right?
Yeah, because of work, basically.
Yeah. Well, the good news is you guys don't have to go to school.
Yeah, college is like right around the corner from me, so it didn't really affect
Oh,
me.
okay. I moved further away from college once this happened. All right, let's talk about unit inelasticity. So really the revenue here, it doesn't really change much whether the price go up or not. And I can't really think of a product like that. It's more about the price, where we're trying to find the maximum revenue. And we'll look more about this. So revenue is maximized when E of X is equal to 1. So keep that in mind. So basically that's what elasticity is about. Let me just grab a couple of problems because there's actually only 6 problems in this homework section. So not much going on here. The only thing that gets difficult in it is probably some of the derivatives. So we'll do probably 2 or 3 questions and we'll move on to the next section of assignment. All right, so this is question number 1 in my MATLAB. So the first thing they're asking us to find is the elasticity, which is just that formula we saw at the top, which is negative x times d prime of x over dx. So elasticity is equal to negative x times d prime of x over dx. So they use p here, but it's in my MATLAB homework question, but that's the same thing as x. So I don't know why they do that, but here we go. So we already know some of these quantities. We know x, but we don't know x right now. X is given in part B, but we do know d of x. All we need to find is d prime of x. So d of x is equal to 209 minus p. So d prime of x be equal to, oh, what would be the derivative of that? Can someone tell me?
Is it -1?
-1. Thanks, Jenny. I mean, we've been doing derivative now for what? Nearly January, February, March. Whoa, 3 months. So now we can substitute this -1 for d prime of x. So this becomes -x times -1 over d of x, which is 209 minus x. So this just becomes x over 209 minus x. So this is our elasticity function. This is part A. Find the elasticity. So we just covered part A. Now part B says find the elasticity at x is equal to 102. State whether it's elastic, inelastic, or as unit inelasticity. So we're going to plug in 102 here. So we're finding E of 102. So it's 102 over 209 minus 102. What do we get for that? And they want to answer as a fraction, so leave it as a fraction. So that'll be 102 over 107. Does anyone agree with that? All right, so back to the question now. Is it elastic, inelastic, or as unit elasticity? Which one is it? Do you remember? So remember,
Elastic.
it is what?
Inelastic.
It's inelastic, and Reginald's saying elastic. So you have conflicting answer. Anyone else? All right, so first of all, is this greater than 1 or less than 1?
Less than 1.
This is less than 1. So it's less than 1. And if we go back up here, we said when E of x is less than 1, it's inelastic. So the answer to this is it's inelastic. And I see Reginald updated his answer. So we're all in agreement now. So section C, so that takes care of section B. The values of P for which total revenue is maximized. The value of X for which so how do we do that? Well, we're going to go back to this last formula. See, revenue is maximized when E of X is equal to 1. So all we have to do is take our E of X function right here and set it equal to 1 and solve it. So we're going to do part C, x over 209 minus x is equal to 1. Now we can take the cross product here. So this becomes x is equal to 209 minus x. Then we can add x to both sides. So 2x is equal to 209. So x is equal to 104.5. So when the cost is $104.05, that's what they're going to have to sell a product. That's when they're going to make their maximum profit. All right, let's do another question. Any question on this one before we move on? When they're all pretty much the same process, right? We're gonna I'm looking for a more challenging type of problem. So this is number 3. So we have d of x or p, whatever they want to call it, which is 324 minus x. We're going to find the derivative of that because we know E, the elasticity, E of x is equal to negative x times d prime of x over dx. So let's find the derivative of that. Now, so this is going back to some real old school rule. First, we have to convert this to an exponential form so that it's 1/2. And now we're going to apply the chain rule to it. So we're going to take the 1/2, if you recall, multiply by here, subtract 1, and then times it by the derivative of the inside. So d prime of x is equal to 1/2 times 324 minus x to the negative 1/2, because we subtract 1 from the exponent, times the derivative of the inside, which is, what's the derivative of the inside? Close, Martha. Negative 1, right? Yeah, be careful on the signs. So this becomes negative 1/2 324 minus x to the negative 1/2. All right, so let's just stick that into our formula. So now we can find the elasticity. It's negative x times d prime of x over dx, which is equal to negative x times 1/2, negative 1/2, times 324 minus x to the negative 1/2 all over d of x, which is 324 minus x to the positive 1/2. If we use the exponential form from up here. So hopefully I haven't lost anyone yet. So all of this, is just being transferred over to here, which is the same thing in the formula. So all of that is just this. No, it's just a matter of simplifying this. So this will become a positive x because of the double negative. And actually, we will only have x on the top. The 2 will be on the bottom because of the fraction. And we're going to have 324 minus x to the 1/2 times 324 minus x to the 1/2. Because of the negative exponent here, when we move it to the bottom, it's going to become positive. So this just becomes x over 2 times 324 minus x. Is everyone okay with that? What we did here, in case you're wondering, for these two, we're multiplying. And when we multiply, remember we add the exponents. So it's 1/2 plus 1/2, which gives us 1. So that's our e of x. Did I lose anyone on the derivative or on just the simplification? All right, let's look part B. Part B says find elasticity when P is equal to 106 and state whether it's elastic, inelastic, or as a unit in elasticity. So we're going to plug in 106 into this problem. So for part B, we're going to do E of 106, which is 106 over 2 times 324 minus 106. Can someone give me an answer for this, please? (106 over 436). Anyone else confirm that?
He's right.
He's right. I didn't know that it was right. Just want to make sure. All right, I'm just looking for the next problem here. So this answer is correct. So elastic, inelastic, or unit in elasticity?
Inelastic.
Inelastic. What does that mean to you? What does that mean? It's more important to even know what it means, right? It means that the price basically won't affect our profit line, but people still are going to buy it. Yeah, Samir, it's less than 1, but what does it mean? It's got part C. Because you always want to know, whether it's elastic or inelastic. Oh, and even more importantly, what we want to know is, where do we maximize our revenue? How do we maximize our revenue? Maximum revenue occurs where E of X is equal to 1. That's how we maximize our revenue. And E of X was from up here, X over 2 times 324 minus X. So we have to solve this to figure out where, that cost that's going to maximize our revenue. So once again, we can take the cross product. So this becomes X is equal to 2 times 324 minus X. So X is equal to 648 minus 2X. Can you guys still see my screen? Okay. Because my other computer is reconnecting, so I wasn't sure. All right, so 3x is equal to 648, because what I did was I added 2x to both sides to cancel that. So we're just solving this. We're dividing by 3. So x is equal to 216. So at $216, this is where we're going to maximize our revenue. So all these problems are pretty much the same. What's going to change? The derivative. So let's just do one more just so we can get through the derivative. Number 4. So we're doing just about half the homework problem, which I figure it's a good percentage. Press on. Well, that's number 4. So as you can see, basically identical to the 2 previous problems. So we're going to find the elasticity, which is once again E of x. So E of x, which is negative x times d prime of x over d of x, or p, if that's. So let's find the derivative. So we know d of x is equal to 500 over p plus 8 to the second power. And there's two ways you can do the derivative here. You can do it as it is, which I really don't like, or we can do the quotient rule, which is the way I don't really like. Or we can rewrite it, and so we can move it up to the top, so it becomes p plus 8 to the negative 2, and use a chain rule, which to me is a little simpler. So d prime of x would be negative 2 times that, which is negative 1,000, times p plus 8 to the negative 3 power, because we subtract 1 from the exponent, times 1, which is the derivative of the inside, which is just negative 1,000 p plus 8 to the negative 3 power. Alright, so let's find our elasticity now. Which is negative x times all of this, which is d prime of x, which is negative 1,000 times p plus 8 to the negative 3, all over d of x. Sorry, which is 500 times p plus 8 to the negative 2 power. So this becomes 1,000x because of the double negative. We're actually going to move this down to the bottom, the negative exponent. So this becomes 500 times p plus 8 to the negative 2 times p plus 8 to the 3 power. And we can do a little simplification here, because this 500 will cancel with a 1,000 to give us 2. So that becomes 2x on the top. We can actually combine these two on the bottom. Since we're multiplying, we can add the exponent. So it's negative 2 plus 3, which just becomes 1. So in the denominator, we only ended up with, and I will keep writing p and no one because of the problem, but it's actually x, okay? Or if you want to use a p. So it becomes x plus 8. Sorry about the p's. We probably should keep it as p. All right, so this is our elasticity. Is everyone okay with this?
I'm sorry, Professor.
Yes.
What happened to the exponents of negative 2 and 3? What happened to those?
Well, so we're multiplying these two, right? You agree?
Yes, agreed.
All right. So let's say we'll go back to something even simpler. Negative 2 times x to the 3. When you multiply these, what do you do? What are you going to get?
Oh, you add the
You
exponent.
add the exponent. And what do you get?
It'd be 1.
Very good. So this is why on the bottom we just have x plus 8 to the 1 power.
Oh, okay. Got it. Thanks.
All right, no problem. Anyone else with any questions? Because I know sometimes I just take stuff for granted because, you know, in my mind it works a little different. So if I skip any steps, just let me know. Or if I don't explain it enough. So that's our elasticity. What else do they ask us to find? Find elasticity at p is equal to 7 and state whether it's elastic, inelastic, or unit elasticity. So we're finding E of 7 is equal to 2 times 7 over 7 plus 8, which is 14 over 15. By now we know that this is the easy part, right? The difficult part is actually finding the elasticity's function. And part C, sometimes a little challenging too. The value for P for which the total revenue is maximized. So we know the total revenue is always maximized when E of X is equal to 1. So wherever E of X above there, where the red asterisk is. So we have 2x over x plus 8 is equal to 1. So it's just a matter of solving this again. So this becomes 2x is equal to x plus 8. Subtract x from both sides, x is equal to 7. And this is why I was kind of saying maybe we should keep it as a p, because this is actually the price at which, you know, a revenue is going to maximize. So for at $7, this product will maximize its revenue. This is what we need to sell for.
Is it not $8?
Oh, 8. Thank you, Jenny. I subtracted 1 from both sides. My bad. I mean, I subtracted 1 from the 2 and 1 from the 8. Yeah, can you imagine doing all that great math and come down here and just make a simple error like that? And my MATLAB tell you what? It's wrong. Any questions so far on elasticity? No? That's great.